Next, we can look at finding vertical asymptotes for a rational function by investigating the function itself. The process is actually quite similar to what we did for finding the domain, but we introduce one more step. We need to begin by first simplifying the given function, and then set the denominator equal to 0. And solve to find any restricted values. So we're finding restricted values for the denominator, but not until we first simplify the function as much as possible. In example 5, we have the function 10x over x plus 17. There's nothing that will factor or simplify here, so we set the denominator equal to 0, which gives us x equal negative 17. So this is our vertical asymptote, our one and only vertical asymptote for this rational function. In example 6, we want to first begin by factoring the numerator and denominator. The numerator here will factor as 5x minus 4 times 4x plus 5. And the denominator will remain as 4x minus 5. In this case, even though we were able to factor, nothing cancels, so we still just take the denominator, set equal to 0, which tells us that we have a vertical asymptote at x equals 5/4. In example 7, we again want to look at factoring this expression. The numerator will factor using difference of squares. And the denominator, we can factor out an x that's common between those two terms to get x times x minus 1. X squared minus 1 in the numerator will factor again by difference of squares. To get us to our fully factored expression. If we look at this, now we have two restricted values for our function, 0 and 1, if we were just to consider the denominator set equal to 0. But if we first simplify by canceling out x minus 1 over x minus 1, we now have a reduced function, or a simplified function, where the only factor that we have in the denominator is x, which tells us that our only vertical asymptote will occur at x equals 0. And we want to specifically note that there will not be an asymptote at x equals 1. Even though the domain of our function restricts x equals 1 from being included, we only have an asymptote at x equals 0, because we always consider that simplified function and then identify any zeros in the denominator.